This lesson is on scientific notation, which I understand is a review for you, so hopefully this won't take too much to get going. Here it says in an ordinary quarter, it contains about, that is a huge number of atoms, 97 and then a 7, and then we have a ton of zeros after it. And it says the average size of an atom is about 0.000003 centimeters across. Those are really, really big numbers and really, really small number. It says the length of these numbers in standard notation makes them awkward to work with. First of all, it's hard to pronounce what numbers they would be. And then there's just a lot of writing. So scientific notation is a shorthand way of writing such numbers. So numbers written in scientific notation are written as two factors. One of the factors is a number greater than or equal to 1, but it's less than 10. So it can be anywhere from 1.9999999, etc., to 9.999999999. It just can't bump up to 10. And then the other factor is a power of 10. So recall that if we increase the exponent by a power of 10, in a power of 10 by 1 is the same as multiplying the number by 10. So watch what happens. If I have 2.345 times 10 to the 0, I don't move the decimal at all. But if I have that same number times 10 to the 1, I move the decimal over 1, and now this number is 23.45. If I have that same number and I have it to the power of 2, then I move the decimal over twice. So it's 234 and a half. If I have that same number times 10 to the third, I move the decimal 3 places to the right, and now it's 2,345. Conversely, if I have negatives, then I'm going to go to the left. You go to the direction of the negatives. So again, times 10 to the 0, don't move the decimal, but times 10 to the first power, it becomes this number now. I move it 1 to the left. So 2,345 10,000ths. And then with a negative 2, I have to move it 2 to the left. Well, here's 1, but to have my placeholder, I have to put a 0. So it's 0.02345. So 2,345 hundred thousandths. And then negative 3 moves it 3 over to the left, so I have to put 2 zeros in its place. So let's go ahead and practice writing these numbers in standard notation. If it's a positive exponent, I move the decimal 2 places to the right, or that many places to the right. So here this number just becomes 254. Negative, you move it to the left. So 1, 2, I have to put a 0 to hold my place. To the right, 1, 2, 3, anytime I have to hold a place, you put a 0 in there. So this number becomes 1,140. And to the left, because it's negative, so 38 hundredths. Let's try another one. This one I'll move to the right 5. So there's 1, 2, and I have to add 3 zeros. So 8, 5, 9, 0, 0, 0. So 859,000. This one again goes to the right. There's 1, 2, 3, and I need 3 zeros after that to make up my 6. So 3,331,000. This one's to the left. There's 1, so I have to put 2 zeros to make up the 2, 3 for the 3. And then this one's 4 to the left, so there's 1, so I need 1, 2, 3 zeros to hold my place value. Okay, so that's changing it from scientific to standard. Now we're going to go back the other way, writing numbers in scientific notation. So for numbers greater than or equal to 10, we're going to use a positive exponent. For numbers less than 1, we're going to use a negative exponent. So 56 is this number right here. It's really 56.0. And I need, remember, in scientific notation, there's the two factors. The first one is a number equal to 1, but greater than or equal to 1, but less than 10. So I can't use a 56, I can use a 5.6. Times 10, I move in it one place, so it's 10 to the first power. because if I were to multiply 5.6 times 10, it'd make a 56. Here I need to make this 9.3, so you move it. And if this number gets bigger, then I have to use a negative exponent, and I moved it 2 spots. If this number gets smaller, I use a positive exponent. So this number is going to get bigger. It's going to get to the 6 times 10, and it's 1, 2, 3, 4, 5. So it's negative because the number got bigger. This number is going to get smaller, 5.226 times 10, and the decimals here, 1, 2, 3. So again, if the number gets smaller, it's a positive exponent. If the number gets bigger, it's a negative exponent. This number is going to get bigger, so it's 4 times 10 to the negative 2. I moved it 2 spots. This number is going to get smaller. So when the number gets smaller, it's a positive exponent, and I moved it 1, 2, 3, 4 spots. Okay, to compare two numbers written in scientific notation, first we're going to compare the powers of 10. The number with a greater power of 10 is greater. If the powers of 10 are the same, then you're going to compare the values that are between the 1 and the 10. So here, the major components of human blood are red blood cells, white blood cells, platelets, and plasma. A typical red blood cell has a diameter which is halfway across the cell, or I'm sorry, all the way across the cell, of approximately 7 times 10 to the negative 6 meters. A typical platelet has a diameter of approximately 2.33 times 10 to the negative 6 meters, which has a greater diameter, a red blood cell or a platelet. Well, we're looking, and here they have the exact same power of 10. They're both negative 6, so I'm going to look at the 7 and compare it to the 2.33, and 7 is greater. So in this case, the blood cell, the red blood cell, has a greater diameter. Here we're just looking at the numbers 2.7 times 10 to the 13th, 2.7 times 10 to the 9th. These values are the same, so you look at the power on the 10. 10 to the 13 is bigger than 10 to the 9th. Okay, Jupiter is about 778,120,000 kilometers from the Sun. Write this in scientific notation. So the decimal has to go here, so 7.7812. You can drop off the zeros at the end, you don't need them. And remember, this number got smaller, so I'm going to end up using a positive exponent. I'd start down here, and I move it 1, 2, 3, 4, 5, 6, 7, 8. So times 10 to the 8th kilometers. And finally, the E. coli bacterium is about 5 times 10 to the negative 7 meters wide. A hair is about 1 times, or 1.7 times 10 to the negative 5th meters wide. Which is wider? Well, here we have a really hard time. We can't really compare the 5 and the 1.7. We can look at the 10 to the negative 5th and the 10 to the negative 7. Let's go ahead and just write these numbers as in standard form. We can do that because these aren't the same power. Those aren't the same factors. So 5 times 10 to the negative 7, I have to move the decimal 7 spots. So there's 1. And 6 zeros, 1, 2, 3, 4, 5, 6, 5. And 1.7 times 10 to the negative 5, I move it 5 places. So there's 1, and I need 4 zeros, 1, 2, 3, 4, 1, 7. Well, this one has lots more, well, not lots more, but it has more zeros, so this is going to be a smaller number. So which one is wider? The hair is wider. Not real wide, but it is wider. All right, if you want to get started on your assignment, you are welcome to do so. You don't have to, but this will be your assignment for Wednesday, due Thursday. So it's lesson 3.3, page 102 to 104. Problems 11 to 20. 22 to 32 even, 33 to 36, 38 to 42 even, 43 and 46. So there you go if you want to get started with those.